To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Now we are going to start the exercise of this lesson. So as usual, you all have to do all the exercises, all the questions by yourselves, answer all the questions. And when I explain, check whether your answers are correct or not. Okay? Right. So we are going to start with the exercise given in the textbook first. Right? Select the appropriate word from the brackets and fill in the blanks. Number 1. Clear umbra can be obtained by a candle and electric torch bulb. Now, when we consider the formation of umbra, you all know that umbra or the shadow has two parts, umbra and penumbra. A penumbra is formed because light rays are escaped, emerged from the sides of the object, right? So, for this one, what we can do is, we did this activity as well, what we can do is, we can increase the distance between the object and the source of light. Okay, children? But here, we have to check by what type of source of light we can obtain a clear umbra. Do you remember I explained y'all another method of obtaining a clear or sharp umbra, children? I told y'all we can use a narrow source of light. Okay, children? So when we consider the candle and an electric torch bulb, the candle is a narrow source of light. So when we consider the electric torch bulb, light could, because it's a kind of broad source of light could escape through the edges of the object and the penumbra is formed. When penumbra is formed, the sharpness of the umbra reduces, right? So clear umbra can be obtained by using a narrow source of light. So in that case, that is a candle. Right? We have to write the appropriate word from the brackets and fill in the blanks. So we will write the answer. A candle. Right. A mirror is used to diverge a parallel beam of light. So what are considered as divergent mirrors, children? You all know that using convex mirrors, we can diverge a beam of light. So when a parallel beam of light is directed towards a convex mirror, what happens? It gets diverged. Right? So when you consider, I told you all, when we draw this diagram, you have to draw it with the dotted line, and then you have to extend the lines. Right? Okay. Right, children? Okay. So when a convex mirror is used to diverge a parallel beam of light, right? The answer is convex. Using a concave mirror, what happens? When a parallel beam of light falls onto a concave mirror, all the light rays collect at the same place. Okay? So they are used to converge a parallel beam of light. Now here, convex mirror is used to diverge a parallel beam of light. Okay? Images formed by plane mirrors are always equal to the object, smaller than the object. It's very easy. It's equal to the object. Equal to the object. Right? Images formed by convex mirrors are always, there's only one type of images formed by convex mirrors. What is that type, children? Always upright, always smaller than the object, and always virtual, right? So images formed by convex mirrors are always upright. Inverted images are formed only by concave mirrors, okay? upright. Which mirror should be used to obtain inverted images? As I told you all, when we use plane mirrors, always upright images are formed. Even when we use convex mirrors, always upright images are formed. The only instance where an inverted image is formed is using a concave mirror, right? Concave, right? Clear umbra can be obtained by a candle. A convex mirror is used to diverge a parallel beam of light. Images formed by plane mirrors are always equal to the object. Images formed by convex mirrors are always upright. Concave mirrors should be used to obtain inverted images, right? Okay, next one. Select the correct answer. Let's read. Which one of the following is not a property of an image formed by a plane mirror? What are the properties of images formed by plane mirrors? The size of the image is equal to the size of the object, right? Image distance is equal to the object distance, and they are always upright, they are always virtual, which means we cannot take them onto a screen, right children? Let's see. Ability to take onto a screen. Now here asks, which one of the following is not a property, right? Can we take the image onto a screen? No. So ability to take onto a screen is the answer, but we are going to go through the rest too. Upright, equal to the size of the object, and also laterally inverted too, right? All these are characteristics of images formed by plane mirrors. The not a characteristic is this, right? A property of an image formed by a convex mirror is, when we consider the convex mirrors, only one type of images are formed. They are always upright, they are always virtual, they are always smaller than the object, right? Inverted, no. Ability to take onto a screen, no. They are always virtual, right? Smaller than the object, correct. Larger than the object, no. They are always smaller than the object. So a property of an image formed by a convex mirror is they are smaller than object. The angle between two plane mirrors to obtain three images should be. Now if you remember this one, you can just underline it has to be 90 degrees, right? So I will show you. So when we use, you remember that we used the number of images formed is equal 360 degrees divided by the angle between mirrors minus 1. This is what we used, right? So as we did this activity, if you can remember it's 90, we can find it out. Otherwise, using this formula, we can easily find it out, right? So the number of images formed here, given the angle between two plane mirrors to obtain three images. No? Here it should be 3 equals 360 divided by, we don't know the angle, we have to find the angle. We'll consider the angle as x minus 1. Right, so we will take this 1 here, it becomes 3 plus 1. This is minus 1, when it comes here it becomes plus 1 equals 360 divided by x. Right children? Then what happens? So this becomes 4. Therefore cross multiplication, this goes here, this comes here, which means x equals 360 divided by 3 plus 1, 4. What is the answer? Here 4 into 9, 90 degrees. Right children? X equals 90 degrees. The angle between two plane mirrors to obtain three images should be 90 degrees. Okay. The type of mirrors that should be used to form an inverted image on a screen is, what is that, children? Inverted image is formed only when you use concave mirrors, right? Convex, concave, plane, all given above. Concave. Right, children? So, which one of the following is not a property of an image formed by a plane mirror? Ability to take onto a screen. They are always virtual, so we can't take them onto a screen, right? The property of an image formed by a convex mirror is they are always smaller than the object, right? The angle between two plane mirrors to obtain 3 images should be 90. The type of mirrors that should be used to form an inverted image on a screen is concave. So we have completed the exercise given in the textbook. We are going to do some extra questions too. We'll move on to the next. Right. Exercise number 1. Underline the most suitable answers. So in these type of questions, 4 answers are given. You have to read all 4 answers very well and you have to find the most suitable answer. Right? Shadows are formed because. What is the reason for the formation of shadows? When light falls on an opaque object, because light does not pass through opaque objects, the shadow is formed, right? The light travels through transparent objects. No, not because of that. The light travels through translucent objects. The light does not travel through opaque objects. Yes, that's the answer. The source of light present away from the object. No. Answer number 3. Right. The light does not travel through opaque objects, right? Not a characteristic of the images formed by plane mirrors. Let's go through this. Size of the image is equal to the size of the object. That is a characteristic. You have to find not a characteristic. Distance from the mirror to the object is equal to the distance from the mirror to the object, which means object distance is equal to the image distance. That is also correct, right? Lateral inversion, that's also correct. Real images, no. Real images could be taken onto a screen, but we can't take the images formed by the plane mirrors on a screen. Therefore, not a characteristic of the images formed by plane mirrors is the last one, real images. Right, number 3. An inverted image can be obtained using. What is the only instance where we can obtain an inverted image? Plane mirrors always make upright images. Convex mirrors also always make upright images. So, concave mirrors only make inverted images. Plane mirrors, convex mirrors, convex and concave mirrors. Answer is 3. Concave mirrors. The number of images formed when the angle between 2 mirrors is 90. Now we just finished this type of question, the similar question, that is 3. 3, 5, 7, 11. Right? When a parallel beam of light falls, which type of mirrors reflect the following A and B beams respectively? Right? So, when a parallel beam forms, now this is a converging. A is converging beam. This is a parallel beam. Parallel beam. So, what type of mirror can change a parallel beam of light into a converging beam, children? That is concave mirrors. Therefore, A should be concave mirrors. Right? What about this? By which type of mirrors parallel beam of light is sent away as a parallel beam? That is the plane mirrors. Right? So, let's consider if this is a plane mirror. Right? If a parallel beam of light falls on a plane mirror, remember children, after reflecting, it goes as it is, right? It comes as a parallel beam. After reflecting, it goes as a parallel beam too, right? So, this should be plane mirrors. Okay? So this should be concave mirror. This should be plane mirror. What about the convex mirror? A parallel beam of light is converted to a divergent beam. Okay? So the first one should be concave mirror. Second one should be plane mirror. Answer number 2. Here convex and plane? No. Here concave and convex? No. Plane mirrors and concave? No. Answer number 2 is the answer. Right. Number 6. The number of images formed when the angle between two mirrors is 60. Maybe some of you can remember, but we will calculate this. So how to calculate this? You have to divide 360 by the angle given, 60 minus 1. Right? So how to do this one? You can cut 0 to 0. 1, 6. Here 6. 6 minus 1, 5. So what is the answer then? 5 images are formed. Okay? The number of images formed when the angle between two mirrors is 60. What is the answer, children? 5. 5 images are formed. Okay. What should be at position AB in the following diagram? This is AB. You all can see a parallel beam of light is coming towards AB. And it reflects the light. After reflecting, they meet at the same place, the place where the spot of light is formed. What type of mirror is this? Which means a parallel beam of light is converted to a convergent beam. So what type of mirrors can convert a parallel beam of light into a convergent beam? Concave mirrors. Okay. A concave mirror, a convex mirror, plane mirror, thin piece of glass. Concave mirror. Not a characteristic of the images formed by convex mirrors. Okay. Always smaller than the object. It is a characteristic. What are the characteristics? Always smaller than the object, always upright, always virtual, right? Always larger than the object, no, it's always smaller. Always upright, correct? Cannot be obtained on the screen, which means virtual, yes. Answer is always larger than the object. Right, children? Exercise number 2. We have right answers. What are the main factors that must be fulfilled for the formation of a shadow? A shadow is formed because light cannot pass through opaque objects. Therefore, there should be an opaque object and there should be a source of light too. Okay, even though opaque object is there, if there is no source of light, can a shadow form? No. Right, children? Okay. There should be an opaque object, and there should be a source of light. Right? There should be an opaque object. There should be a source of light too. Those two conditions must be there. Name an instance where the nature of shadows was used in the past. It was used to measure the time. Remember, using the sundial, using the direction of the shadow and the length of the shadow, the time was predicted, right? Okay. To measure the time. To measure the time. Right, within brackets, using sundial. Using the sundial. Okay, children. We'll move on to the next. Exercise number 3. A shadow or umbra has two main parts. What are they? So, umbra has two main parts. The dark part is known as umbra and the lighter outer part is known as penumbra. Okay? What are they? Umbra and penumbra. Umbra and penumbra. Okay? Number 2. Name 2 phenomena. Phenomena means incidents. Name 2 phenomena associated with celestial bodies, which means objects present in space. Right? Celestial bodies due to the formation of shadows. What is this, children? Celestial bodies means the objects like stars, planets, etc. Okay? So what are name 2 phenomena associated with celestial bodies due to the formation of shadows. Solar eclipse, lunar eclipse. We learn about that. Solar eclipse and lunar eclipse take place because of the formation of shadows. Okay, children? Solar eclipse, lunar eclipse. Right? Name 2 phenomena associated with celestial bodies due to the formation of shadows, solar eclipse and lunar eclipse. Right? Right. Exercise number 4. Show with the diagram how light is reflected by a plane mirror. So we can show it very simply. How to draw a plane mirror? A straight line. So how to show the front and back of the mirror? You can indicate the back of the mirror by these small lines. Okay? So how to show the reflection? How light is reflected? You can simply draw the incident ray. You can simply draw the incident ray and the reflected ray. Is this correct? No, it's wrong. What is missing here? The arrowheads. You must show the arrowheads too. Right? This is the incident ray, reflected ray. Right, children? Next one. What are virtual images? What is the meaning of a virtual image, children? There are 2 types of images, real images and virtual images. Real images are the images that can be taken onto a screen. Virtual images cannot be taken onto a screen. Okay? So what are virtual images? The images that cannot be taken onto a screen. Right? What are virtual images? They are the images that cannot be taken onto a screen. Okay? Exercise number 5. What are the features of an image formed by a plane mirror? There are 5 features. Let's write them. Okay. Size of the image is equal to the object. Equal to the object. Then upright. Image distance is equal to the object distance. Object distance. Then lateral inversion. And finally, we can't take them onto a screen, which means they are virtual. Right? What are the features of an image formed by a plane mirror? Size of the image is equal to the object. They are upright. Image distance is equal to the object distance, which means the distance from the image to the mirror is equal to the distance from the object to the mirror. Right? Lateral inversion, which means right and left sides are changed. Okay, virtual means we can't take them onto a screen. Okay, what is lateral inversion? What is lateral inversion? Here also we explain, that is the change of when we look through a plane mirror, left and right sides are changed. Okay, right. What is lateral inversion? The phenomenon inversing, the phenomenon of inversing the left and right sides when an image is formed by a plane mirror. Is called lateral inversion. Right, children? What is lateral inversion? The phenomenon of inversing or changing the left and right sides when an image is formed by a plane mirror is called lateral inversion. We'll move on to the next. Number 6. Draw the different types of light beams. How many light beams we learn about? Parallel beam, convergent beam, divergent beam. Okay, let's draw them. Draw the different types of light beams. So when you draw light beams, you have to use straight lines and the direction must be shown with arrowheads. So what beam is this? Parallel beam. Parallel beam. Then another type, divergent beam, starting from the same place. What happens, children? The light rays spread out. Again, arrowheads, straight lines and arrowheads. Right? Divergent beam. And finally, convergent beam. Coming from different directions, light rays gather or collect at the same point. Straight lines and arrowheads again. Convergent beam. Right, children? Draw the different types of light beams. Light beam is a collection of light rays. Okay? Here, parallel beam, light rays are parallel to each other. Divergent beam, light rays starting from the same point and they spread out. Convergent beam, coming from different directions, light rays collect at the same point. Okay? Convergent beam. Next one. Mirrors with curved surfaces are called curved mirrors. There are two types of curved mirrors. Name the two types of curved mirrors. What are they? Convex and concave. Right? Convex mirrors and concave mirrors. Concave mirrors. Convex and concave mirrors. Draw those two types. How to draw the convex mirrors? Convex mirrors are curved outwards, which means the part that is curved outwards is the mirror side. So whenever you draw a mirror, you have to draw the front, you have to show the front and the back of the mirror. So how to show the back of the mirror? Using these small lines. Right? This is the convex mirror. Concave mirror. Concave mirror Here, the side that is curved out inwards is the mirror side, reflecting side. The other side you have to put small lines. Concave mirrors. They are curved inwards. Right, children? Convex mirror, concave mirror. Right? Draw the two types. We'll move on to the next. Number 8. Why are convex mirrors called diverging mirrors? Diverging. That's because when a parallel beam of light falls on a convex mirror, what happens, children? Those light rays, they move away from each other, which means they spread out. This spreading out is known as diverging. Right? Let's write. Why are convex mirrors called diverging mirrors? Because a parallel beam of light falls on a convex mirror spreads out, or we can simply say diverges after reflection. Right? Because a parallel beam of light falls on a convex mirror spreads out or diverges after reflection. Right? Show in a ray diagram what happens when a parallel beam of light falls on a convex mirror. What happens? It spreads out or diverges. That's why they are known as diverging mirrors. Okay? Let's draw this. Convex mirrors. This is the convex mirror. This is the back of the mirror. So you have to draw a parallel beam of light. Parallel beam of light. And you need to draw the arrowheads to show the directions, straight lines and arrowheads. And what happens? We'll use a different color. Then, so they spread out, but at the back of the mirror, they all connect. It looks as if they connect. Therefore, we have to use dotted line at the back of the mirror. Right, children? And the arrowheads. They spread out after reflection. From the surface, they start to reflect. Okay, children? Next one. Why are concave mirrors called converging mirrors? The opposite of this, right? So here what happens? Because when a parallel beam of light falls on a concave mirror, what happens? They collect at the same point, right? So therefore, it is known as, it's collecting at the same point is known as converging. Therefore, they are known as converging mirrors. Okay, children? Let's write. Because a parallel beam of light falls on a concave mirror, collects at the same point. This is known as converging or converges. after reflection. That's why they are known as converging mirrors. Because a parallel beam of light falls on a concave mirror, collects at the same point or converges after reflection. Okay? Showing a ray diagram, what happens when a parallel beam of light falls on a concave mirror? We will draw concave mirror. This is the back of the mirror. Parallel beam of light falls. And the arrowheads we'll use a different color to draw the reflected light. Right, straight lines and arrowheads. They meet at the same point, right? This incident is known as the convergence of light. Okay, children, we'll move on to the next. Okay, exercise 10. Write the characteristics of the image formed when a lighted candle is placed closer to a concave mirror. When an object is kept closer to a concave mirror, what happens, children? Now think of a shaving mirror. So when you take it closer to your face, you can see a bigger image of your face and it is always upright. But can we take it onto a screen? No. Do you remember we did a similar activity to study the nature of these images? We placed a candle in front of a concave mirror like this. Then what happened? We marked 4 instances: A, very close, B, C, and D, away from the mirror, right? So then what happened? When we placed the candle in front of, very close to the mirror, what happened, children? The image formed was larger than the object, upright, but we could not take it onto a screen. All the other instances, B, C, and D, we could take the image onto a screen, but here we could not. Okay, so we will write the characteristics of the image formed when a lighted candle is placed closer to a concave mirror. Okay, let's write upright, larger than the object, larger than the object, virtual, which means cannot be taken onto a screen, cannot be taken onto a screen. Right, children? Write the characteristics of the image formed when a lighted candle is placed further away from a concave mirror. We'll consider it's D. It's the opposite of this. It was smaller, inverted, and it's real because we could take it onto a screen. Okay, so here, inverted, upside down. It was smaller than the object. Smaller than the object. And real, which means can be taken onto a screen. Right? Inverted, smaller than the object, and real, can be taken onto a screen. Right? Number 11. What are the characteristics of the image formed by a convex mirror? There's only one type of image formed by a convex mirror. Shall we write them? They are always upright and they are always smaller than the image, smaller than the object, smaller than the object. Here, they are always virtual, which means we cannot take them onto a screen, right? So when we consider the concave, depending on the place, you all know that the nature of the image changes. Now when it is placed very close, upright, larger than the object, virtual image is formed. But when it is kept away, further away from the mirror, inverted, smaller than the object, real image is formed. But no matter where we place the object when using a convex mirror, always an upright, virtual image is formed which is smaller than the object. Okay, children? We'll move on to the next. Okay. Exercise 12. Specify the type of mirror Specify the type of mirror used for each of the following requirements. Okay. To make a periscope, what type of mirrors were used, children? Two plane mirrors, two similar plane mirrors were used, right? Plane mirrors. For dentists to examine the teeth of patients, here you have to get a larger image. In that case, we use the concave mirrors. Concave mirrors. To make solar cookers, here also concave mirrors, because concave mirrors can converge light, right? So the light rays are gathered or collected at the same point, and that place we can place the pot, right? Therefore, to make solar cookers also, concave mirrors are used. As side mirrors in vehicles, we always use convex mirrors because we can observe a smaller picture of larger area, right? Smaller image of large area could be observed using a convex mirror. Therefore, as side mirrors in vehicles, convex mirrors are used. Convex mirrors. As mirrors in dressing rooms, always plane mirrors. Right? Specify the type of mirror used for each of the following requirements. To make a periscope, plane mirrors. For dentists to examine the teeth of patients, concave mirrors. To make solar cookers, concave mirrors again. As side mirrors in vehicles, convex mirrors. As mirrors in dressing rooms, plane mirrors. We'll move on to the next. Right. Number 13. Define what reflection of light is. What is reflection of light? When light falls on a certain surface, it bounces back or it returns in the same medium. Right? We will write the phenomenon of returning the light rays in the same medium. Only the direction changes. In the same medium after falling on a surface or after meeting a surface. On a surface is called reflection of light. Right? Define what reflection of light is. The phenomenon of returning the light rays in the same medium after falling on a surface is called reflection of light. Next one. What are multiple images formed by plane mirrors? What happens here when two plane mirrors are kept at an angle or parallel to each other? So after keeping it, we have to place an object in between the mirrors too. So when you place like that, what happens, children? More than one image are formed. So this is known as formation of multiple images, right? What are multiple images formed by plane mirrors? Let's write. When two mirrors are kept at an angle or parallel to each other, and an object is kept or placed in between more than one image are formed. This is the formation of multiple images. Right, children? When two mirrors are kept at an angle or parallel to each other and an object is kept in between, more than one image are formed. This is the formation of multiple images. Okay, children? We'll move on to the next. Right. Exercise 14. Write 3 instances where concave mirrors are used in day-to-day life. So when we use the concave mirrors, we can observe a larger image, upright, larger image of an object. Therefore, what are the instances we use? Let's write. We can use them as shave-in mirrors. And we use them to make solar cookers. Reflecting telescopes, and also for the dentist to observe teeth. For the dentists to examine teeth. Right? As shave-in mirrors. To make solar cookers, for the dentist to examine teeth. Right, children? Write 3 instances where convex mirrors are used in day-to-day life. They are used as side mirrors of vehicles, as search mirrors. For security purposes also it's used. In roads to observe the places where you can't observe clear, it's used. In hallways and hospitals and supermarkets also to observe a wider area also it's used. Right? Let's write some of them. As side mirrors of vehicles, as search mirrors, for security purposes. You can write ATM machines. Right? As side mirrors of vehicles, as search mirrors for security purposes, and you can write the other examples too. Okay? We'll move on to the next. Right. Exercise 15. Name the following light beams. Now we are very familiar with them. What type of light beam is this? You all can see the light rays are parallel to each other. This is a parallel beam. What about this? starting from one point, they move away from each other or they spread out. This is known as diverging, right? So this type of beam is known as a divergent beam. Divergent beam. And here, light rays coming from different directions, they collect at the same point. So this type of collection is known as converging, right? So this is a convergent beam. Convergent beam. Right? Parallel beam, divergent beam and convergent beam. This was very easy. We'll move on to the next. Exercise 16. An apparatus used to make a periscope is given below. Right? What are X and Y? What are X and Y, children? They are similar plane mirrors. Plane mirrors are used to make periscopes. Okay? Plane mirrors. Plane mirrors. Write 3 instances where the periscope is used. What are the instances, children? In submarines, it is used to observe the objects or the ships and all the other objects that present above the water level, right? And even in bunkers, we can use it to observe whatever is happening in the above the ground level, okay? And also in nuclear power plants, it is used to observe the nuclear reactions without being harmed, okay, children? And also in tanks and armored vehicles also, periscopes are used. We can use some of them, right? 3 instances. In bunkers, in submarines, in armored vehicles, etc. Right? We'll move on to the next. Exercise number 17. An activity done to observe the nature of images formed by concave mirrors is given here. In the following table, write the nature of images formed when the object is kept at A, B, C and D points. This is the exact same thing we did during the lesson. Okay, children? So the point A is very close to the mirror. D is far away from the mirror. Right, children? B and C present in between. So, point where the candle is kept, A, B, C, D. So, can or cannot be taken onto a screen. When the object is placed close at A, close to the mirror, what happens, children? It cannot be taken onto a screen, and all the other instances, it can be taken onto a screen, right? So, here, cannot, here, can. Whether upright or inverted, when the object is placed very close to the concave mirror, an upright image is formed. All the other instances, an inverted image is formed, right? Here, upright, inverted, here also inverted. What about the size of the image? The first 2 instances, when we place the object at A and B, the images formed were larger than the object. What about C, children? When we place the object at C, the image formed was similar to the object, right? What about D? When we place the object at D, what happened, children? The image formed was smaller than the object, right? So here, larger than the object. Here also larger than the object. Equal to the size of the object. Here smaller than the object. Right, children? So at A, the image cannot be taken onto a screen, that is upright and larger than the object. At B, image can be taken onto a screen, it is inverted and still larger than the object. At C, image can be taken onto a screen, inverted and equal to the size of the object. Right? At D, it can be taken onto a screen, inverted and smaller than the object. We'll move on to the next. Exercise number 18. Label the umbra and penumbra of the following diagram. So what is umbra? The darker middle part is called umbra, and the outer part is known as penumbra, and it is lighter. Okay? This is penumbra, and this is the umbra. Right? How does the above shadow change when the ball is brought towards the screen? Right? So when the ball is brought towards the screen, which means the ball is moved away from the torch. So you all know that when the distance between the ball and the torch increases, what happens to the umbra? Umbra becomes sharper, penumbra gradually disappears. Right, children? The penumbra gradually disappears and umbra becomes sharper. That happens when the distance between the ball and the torch increases, which means when we take the torch away from the ball. Now here, ball is taken away towards the screen, which means this distance still increases. Right? When you take this away from this torch, what happens? The distance between the torch and the ball increases. So the same thing happens. Right? How does the above shadow change when the ball is brought towards the screen? Let's write. The umbra becomes sharp. The penumbra gradually disappears. Right, children? How does the above shadow change when the ball is brought towards the screen? The umbra becomes sharp. The penumbra gradually disappears. Okay? Right. Exercise 19. A candle is placed in front of a plane mirror as given below. This is the candle, this is the plane mirror. 3 images are given, A, B, C. From A, B and C, what is the best image that can be considered as the image of the candle? Now, when you consider the images formed by plane mirrors, what are the characteristics, children? The size of the image is equal to the size of the object. Right? The image distance is equal to the object distance. What is the meaning of image distance? The distance between the image and the mirror. What is the meaning of the object distance? The distance between the object and the mirror. So the distance between the image and the mirror is equal to the distance between the object and the mirror. And lateral inversion takes place. They are upright as well. Okay, children? Okay. So according to these 3 images, what is the best image that can be considered as the image of the candle? Now this is very easy to understand now, right? So out of A, B and C, you have to find an image. The size-wise, it should be similar to the candle, the object, right? So A is smaller than this object, C is larger than the object. Therefore, the most possible one can be B. Not only that, when you consider the distance between the candle and the mirror, and the distance between this B and the mirror, B means this image and the mirror, they look quite similar. But when you consider this distance and this distance to this other A and C, now between the A and C, this distance is less than that of this object distance, right? This is called the object distance. Object distance. This is called the image distance. Image distance. Right? So when you consider this image distance, it is higher than that of this object distance. Therefore, what is the best image that can be considered as the image of the candle? That is B. Give reasons for your answer. We will write because the size of image B is equal to the object. The second one, because the distance from B to mirror is equal to the object distance. Okay? Because the size of image B is equal to the object, because the distance from B to mirror is equal to the object distance. Object distance. So this is why we can easily come to the conclusion that B is the image of the candle. Right, children? We'll move on to the next. Right, exercise number 20. This is the last exercise of this lesson. Right? A diagram of a kaleidoscope is given below. Now you know how to make a kaleidoscope like this. It's very easy to make a kaleidoscope like this, okay? How many strips of plane mirrors are needed to make a kaleidoscope? How many plane mirrors, children? 3 plane mirrors. 3 plane mirrors. 3 plane mirrors are used. Right, children? Write 2 instances where the kaleidoscopes are used. Now, when you look through the open end of the kaleidoscope and when you put different colorful things into the kaleidoscope, and when you look through the other side of the kaleidoscope, you can see beautiful various patterns, right? Because of this reason, this type of kaleidoscopes can be used in textile industry to design textile and also to design floor tiles and wall tiles as well, right? So 2 instances in textile industry, tile industry, in textile industry and in floor tile and wall tile industry as well. So we have completed the entire lesson. We did a lot of experiments. We learned a lot of new topics under this lesson. Not only that, we answered a lot of questions too. So I hope you have a better understanding on the special topics of this lesson. So I hope you have understood how to answer the questions like this, and if you made any mistake, you can answer the same questions again and you can practice more.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.